Hi everyone and welcome back. In this video, we're going to discuss descriptive analytics and particularly what is data. On the outline, first question is, what is data? These are facts and statistics collected together for reference or analysis. It has to be in a digital form so it can be transmitted and processed further by different tools. Data in general is classified as either structured or unstructured. Look at this diagram. A structured data is something that can be displayed in rows and columns consisting of numbers, dates, strings, and unstructured data, on the other hand, are primarily from images, documents, emails, and spreadsheets. So the tweets, posts, and comments from various sources are good examples of unstructured data. So what is interesting to note is that 80% of actual enterprise data is unstructured, meaning there's not really much of a format that's easy to query. And that also means that there is a lot of work to do in converting unstructured to structured data. So which is why this is one of the challenging part of data analytics. Structured data, by definition, is a collection of objects that has some attributes. Let's say, for example, a customer. So a customer may have an attribute like a customer number, last name, first name, contacts, address, and so on. This is a simple data set. So you have attributes and objects. And in this data set, for income and marriage is shown where each record is actually an object, or in statistics, we call that an observation. So we have 10 observations all in all here, comprised of several columns representing the attributes such as refund, marital status, taxable income, and cheat. There are three categories for a structured data set. We have a record type, we have the graph types, and the ordered types. So actually, it depends on what kind of data set is presented to you, the question that you can ask, and the answer that you can have. Let's take a look at an example for the record. You see, the illustration there is a simple table. For a graph, you have nodes and vertices. And for an ordered type of data set, you have a time series. The data matrix is a typical data set comprised of rows and columns. So this is straightforward. So from here, you could actually ask the question, how many individuals, married individuals, have a refund on their tax? Or how many single individuals have a taxable income higher than 100,000? So it's just a typical rows and columns. Okay? This is an extension of the previous data set, which we call a document data set. The intersection is the number of each attribute occurring in the object. Let's say, for example, this is a book. We have 3 documents here, and we are trying to look for the word team. The word team is present 3 times in document number 1, while score occurred once in document number 3. So you could see some kind of a summary for these figures. So the question of how many is easily answerable by this kind of data set. But to answer in what paragraph this word was present, then that will be quite hard to answer. Another is what we call a market basket or a transaction data set. So the transaction data is where multiple items comprises one record entry. So for each record, you have either one entry, two entries, or more. Okay? So again, in this example, you have a grocery store. The set of products purchased by a customer during one shopping trip constitute that one single transaction. Next, graph. Of course, a graph which comprises of vertices and edges. The circles are the nodes or the vertices, and then the edges are the lines with arrows. So we have here A, B, C, D, E, and D and E as the vertices or nodes, and you have the lines representing the edges. We have some values representing the weight of those lines. This is structured. Why? Because it follows the graph structure. A graph structure actually can be represented as an adjacency matrix where the size is the number of vector columns times the number of vector columns. So you have how many vectors there? 5 vectors times 5 vectors, the size is 25. Okay? There are many types of data that are represented as a graph. One is when you look at the road, the road network, that is best represented by a graph. When you have acquaintances in Facebook, your friends, my friends, and the connection among those people, that is best represented by a graph. Anything that has connection from one point to another, it is best represented by a graph. And did you know that if only all the problems in the world can be represented as a graph, then there could be a solution for each of those problems because of the numerous number of algorithms that works on a graph. Another type of structure is the sequence transaction data set. So here we have a data along with the sequence in which the events happen. So sequence analysis is very popular to predict the occurrence of an event through a pattern from a historical data. Next is the ordered data. Here, in a time series data set, the data occurs sequentially over a period of time. The sample sales is plotted using year and quarter grouping entry. So you could see from the table, from 2001 up to 2005, quarter to quarter, you could see the sales. And when you plot that in a time series data set, you could see some progression. It could either go up, go down, or become stable. Right? So these are good, actually, again, to determine the history and then predict a possible sales in the future to come. Unstructured data is generally everything else that was not mentioned. So data that isn't structured for machines to understand. Examples are scanning of social media to get sentiments of trending. So if you have numerous tweets, how did you know what is the trending sentiments of people? By simply getting the hashtag, or you would like to read along what they have posted, but remember, it could have been tweeted in English, in Tagalog, or in a combination of those two. So it's really quite difficult because some people may tweet in a few sentences or a few words, and some people would have to write that in a different manner. So that is a classical example of unstructured data. There is an internal structure, but it's not structured anyway, which is easy to query. So other examples for unstructured data, you have sensor data, images, audio files, emails, social media, and many more. So again, unstructured data comprises 80%. So if there is a way that business analytics, the business intelligence would be able to gather information, gather relevant information from those unstructured data to help the business, to help the organization, then we have the data, but we need to know the means of extracting those information. Okay? So that's it for data, and see you again in the next videos.